So, hello everyone. Today I'm going to talk about camera APIs, and I'm not going to talk about Android. So, but I'm calling it Android Camera3 because it's the hardware API, the hardware design that Android has forced on all the SoC that people want to use in phones. So that has become very predominant, and there's a model, basically the thing that enables. And I'm going to talk about how we can enable these kind of features in GStreamer that right now we don't have. So who am I? My name is Olivier. I've been working at Collabora since 2007, and I've been working on GStreamer since 2007. At first, I did video calls. I worked for 5 years building a video call framework that was used by a small Finnish company that used to make cell phones called Nokia. And we helped our customer using all kinds of things with GStreamer. Lots of hardware integration projects, and we do a lot of work helping people use the hardware in their chips and their SoCs effectively using GStreamer. So what is Camera3? It's a new style of camera API that is different from the previous one that people are used to. It was introduced by Android 5.0 in 2014, not 4. It exposes the kind of feature that you have in modern SoCs. So what's a modern SoC? What kind of feature does it have that a traditional, like your traditional USB camera doesn't have? So as I said, it's used in all phones. The Apple phones has something similar also. It's made of multiple hardware blocks, and there's ways to configure these blocks to produce different pipelines. It's somewhat configurable, but not that configurable. So there's not that many pipelines that you can make. And most of the hardware has been designed to achieve a very small number of pipelines that are needed by Android applications. And often it's signal level transfer, so it will transfer data between the different blocks, not one frame at a time, but often like one pixel at a time over like a direct connection, or one line at a time. So it's relatively fast, and it's all hardware, right? So it's, in the end, only the end result might end up in RAM. What kind of features do these chips have? The main feature is that you can have multiple streams from the same sensor going through different paths. So for example, you can get the typical case that you find in many high-end smartphones now is that you have one path to the screen where it will scale it to the resolution of the screen, one path to a JPEG in very high resolution, so when you take pictures, and another path that goes through a H.264 encoder that records to the disk. So you can at the same time record a video, show it on the screen, and take pictures. And this is all enabled by the camera hardware. The other big feature difference is that it's pull-based instead of push-based. So it uses something that they call requests. Request is a request to capture one frame. It's very simple, and it has some parameters. And this means that on every frame, you can have different parameters. So the very, very typical use case is to do HDR. So in HDR photography, you basically take 3 pictures at slightly different exposures, and then you have some clever software to combine them into one nice looking picture. Like the Google Pixel, Google camera has some very clever software now to make really beautiful pictures out of a sensor that's the same as everyone else's. And they use these kind of features to have pictures that are slightly different conditions that they can then process. So it can also do burst captures, so you can just queue requests and fill your queue with requests, and the hardware will process them as fast as possible, so allowing you to capture frames very quickly with one another. And then you can also do traditional video by sending requests on the clock. Let's say every 30th of a second you send a request, and that will give you traditional video. And obviously you can just take a single picture by just sending one request. Which APIs can you use to do that at a low level? So on upstream Linux, there's no API to do that. In practice, there's some bits that exist. So there's something called a media controller, which is a kernel API that looks a bit like GStreamer, where you have nodes with pads that you connect. Huh? It's subdevs, yeah, with nodes that with pads that you connect, and they yes. So you just connect them together, and at some point it ends up at the V4L device. The problem is that when you get to this V4L device, you've lost because it doesn't have a request API yet upstream. So you only have that in Android kernels right now. But to create this pipeline, it's very hardware specific. So you need some piece of user space code that knows the hardware. Android has the hardware abstraction layer. So for each SoC, the SoC vendor writes a bit of software that will call all the right kernel APIs and in the end get you the frames. This is really horrible Android specific code from each of the vendors. And on generic Linux, there's nothing to do that right now. There's nothing standard. Intel, it's going to be presented tomorrow, they've written an iCamera source that does a lot of that, but is very specified to the Intel hardware. It's really an API for the Intel hardware. It's not something that you could use with a different hardware, so it's a bit annoying. On Android, I called it the Camera 3, but if you look at the Java API, it's called Camera 2 to make everyone's lives fun. And that's actually the Java API that drives the AL Camera 3. The NDK also has Camera 2 now, so you can cast it in C++. This is basically the kind of feature that are available to applications now. So we did a project to do a prototype to see could we expose this in GStreamer in a meaningful way that would be GStreamery, but at the same time expose all the features that people expect. And the answer is yes. We came up with a little design. One of the first things we tried was we used base source, and that was a huge mistake because base source assumes that you have one source pad, and in this case we have multiple source pads, and it was a bit of a disaster. And these source pads are request pads, so you can request different streams with different properties. You can request, let's say, a stream that's at different resolution, different things. So using request pad is really a natural model for this. And then we have APIs for the different streams that we put on the different pads, so you can control the different streams separately using APIs that are on the pads instead of the element. So the pads API is for things that are for stream, because there are also some properties that are for all the streams, because all the streams often share some of the hardware. So in most cases, it's the same sensor, that you have one sensor, but then you have different pipelines through the hardware that they can follow. So some of the properties are applied to all the streams, and some of the properties are applied to each stream separately. So for example, a lot of these hardware things have different kinds of effects that they can apply, and these might apply to all the stream and not to one single stream. So there is some work there. And so we're suggesting using just GObject properties on the pads to select the different properties you could have, exposure and things like that. And we're proposing two kinds of behaviors based on the frame rate. Either you request a frame rate of 0, which means that it will only fire buffers if you ask it to. So then we can add an API, an interface, or an action signal to just request one buffer. Or we can have a start-stop method, and after start, it will just request as many buffers as possible, as quickly as possible. And this is used for burst modes that you have in most modern cameras. The other mode is the more traditional mode, where we have a frame rate that's not 0, and then it will just do a time request based on that frame rate to try to get the video at that resolution. We'll also suggest stopping on notlink and restarting on configure so that you can plug and unplug things afterwards to make it easy. What limitations do we have? So this looks all very nice and dynamic, but in practice it's not that dynamic. First, we cannot change the paths once anything is started. So as soon as one path has data flowing through it, we cannot change this path anymore. So the easiest, and this is the same in the Android API. you first request all your streams and then you start using them. So what we suggest doing is that you have to request all of your pads in ready, and then when you go to paused, this is frozen, you cannot change it anymore. Maybe we can do that if there's only more than one stream, because if you have one stream, you could always stop it and renegotiate like we do for regular cameras right now. And also, there are some properties that are declared on streams, but also, surprise, surprise, they apply globally. I'm not sure if that might actually depend on the hardware, and it might also be a surprise to the Android application developer. So maybe we have to be more clever than the Android people and put these on the element, or maybe we just have to accept that we're a bit dependent on the hardware's capabilities there for the behavior. And then there are some limitations that are not really limitations of the hardware, but more of the Android API. So if we build something over the Android HALs, which I think we may have to in the short term, because it's the easiest way to get the user space code that matches the different vendors. One of the things that it requires single-threaded access. The way that the Android middleware uses these HALs is always from a single thread, and this is guaranteed in the documentation. And so it's probably not thread safe at all. So the easiest thing is probably to have our source have one thread that handles it and then pushes the buffers into one queue per pad where they're actually streamed from. This is very specific to Android HAL, but it's kind of a caveat that we had not realized at the start of our project. Then we were very surprised it actually worked in the end. When we read that, we're like, oh, we were lucky. This one was not so crap, but a different one might completely crash randomly. So which implementation do we have? We wrote an implementation. We will not publish it because it's so bad. But we learned everything that we learned here. We learned it by making lots of mistakes. So it's called, written by Nicolas in the back, Vincent Pankerk and Wanchul from my team. And I know we're also working, Justin, I don't know if he's here, is also working on a Android Camera3 place plugin, so that runs over the Android middleware using the NDK. So hopefully that will implement a lot of these things in the right way. So thank you. If you have any questions? Yes.
Did you consider to use the GStreamer controller for these HDR captures? That is one thing that I never got around when I was looking at it. So basically queue controller parameters via GStreamer controller. So
yes. Yes, absolutely. I guess if there are properties, then it's very easy to attach a controller to. Yeah. That's actually an idea we had. Like, you know, if you want to do maybe have a controller that does three different values or something like that, to do different kind of things. So we haven't tried, but we kind of assume that if it's a property, it's very easy to do that. The controller. That's one of the reasons we chose properties as the way to control these things. Yes?
You mentioned you started to use a base source, yeah, and it didn't work, and then you implemented something else. This something else, is it implemented as a base class?
Well,
the multiple source?
Right now we didn't implement something else. We hacked something nastily over base source. So we started with base source, and then we didn't have enough time to change, so we realized it's not a good idea. But let's continue that way. So our prototype, one of the reasons it's so bad is that it actually uses base source, but adds a second pad that's a request pad besides it.
I have just realized that we had a similar problem. We ended up building our own kind of implementation, but we didn't end up having a base class, like a proper base class for multi-source.
Yeah, and I think that will be required, because I said that iCamera source from Intel, they have a fork of base source in there with stuff that you're like, okay, it probably works, but clearly it's base source with other stuff added into it. So we probably need a multi-pad source somehow, base class. Yeah, I guess to do a base class add, we'd have to figure out all the relevant use cases and sit down and think.
Would be nice.
Yeah.
Would your plan for number of pads for that be hardware dependent?
It is. But I think Android has some requirements, so you can probably assume a certain minimum. I think it's 3 or 4.
And then there's a minimum of 4 screens.
Yeah.
And so that could be exposed in the class.
Yeah, or you can just fail the pad creation if you get over the number or something like that. Because in practice, when you request a pad, that will call the relevant functions underneath. And like if it's a media controller, often it's quite, the kernel will tell you no, 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 or will give you the information. So.
With the media controller, you will know because you can involve the balls.
Right.
It's a bit of code, it's quite a thing, but you can involve the balls.
Are there any existing Android Camera 1 API implementations that you know of?
You mean Camera 1, the old one? Oh,
Yeah.
there's a plugin in GStreamer and Jesse Plugins that uses it.
Great.
But Camera 1 is much more simple. It's not request-based. You just say, hey, give me a video, and then it just sends you frames. It works like a USB camera. It's very inflexible, you know?
Yeah.